Potential divider is simply a device that is used to provide a known fraction of a given potential difference. For example, in our two illustrations here, we have this kind of potential divider that we are going to call the fixed potential divider because it has fixed resistances, and so it will give out an output voltage that is fixed. Then we have a variable potential divider. This is the input voltage here, V0, and this is the fraction of this voltage that is being delivered at the end. So a potential divider is basically used to provide known fraction of a given potential difference. For example, if one which is too large to measure easily. So looking at these two potential dividers, we are going to find out the amount of current that is going to go through them. After getting the amount of current that is going to go through these potential dividers, then we are able to establish how exactly we get these output voltages. So now if you look at this output voltage V0, because this is the input voltage. Input voltage V0 is going to be equal to the voltage across this resistor plus the voltage across that resistor. So voltage here is going to be equal to the voltage across resistor 1 plus the voltage across resistor 2. So V0, which is the input voltage, is going to be equal to the current. It's going to be the same current going through this whole resistors and coming like that. So it's going to be current times R1 plus I times R2. So this is going to become I into R1 plus R2 is going to be V0. So it means that if we make I the subject of the formula, the amount of current that is flowing through, that resistor or that circuit is going to be I is equal to V0 over R1 plus R2. So now, having gotten the current that flows through this whole circuit, then now how do we get this output voltage V1, the voltage that is across that resistor, because we are interested in the output voltage since that is the function of the potential divider, to give a known fraction of a given potential difference, and the given potential difference here is this input voltage. This is the fraction that is given out. So how do we get V1? This is current. So V1 is simply going to be current I times the resistance, which is R1. So that's going to be equal to V1 is going to be the current times R1. So we got the current as this. So it's going to be V0 over R1 plus R2, multiply that by R1. So you're going to end up with an expression like this, that R1 over R1 plus R2, multiply that by V0. I've put the R1 here and the V0 there, times V0. And that is going to be the expression that we shall be using when we want to find the output voltage in any potential divider. Find the potential difference across the output of the unloaded potential divider below when the slider is halfway the divider. So the resistance of the divider is 8,000 ohms. This is the divider, the potential divider, and its resistance here, the resistance of that thing is 8,000 ohms. It is 8,000 ohms. This is the output terminal of the potential divider. It is having an input voltage of 100 volts, and they are asking us to find the potential difference across this. Now there are two cases. The first case is when the output here is unloaded. It means that there is no resistor at the output terminal, and this is the first case we are going to handle. In our next example, we shall be dealing with the second case where the potential divider is loaded with the resistor here, and we shall see how we get the output voltage when the output terminal is loaded with the resistor. So for the first case, when it is unloaded like that, they're telling us that the slider is halfway up the divider. This is the slider. if this whole thing is 8,000 ohms and the slider is halfway up, it means that this will be, if the whole thing is 8,000, so this will be 4,000. The resistance from here to halfway is 4,000, and the resistance of the upper part is also 4,000. So it means that R1 will be 4,000 and R2 will be also 4,000. So now for us to find the voltage output here, let's call it voltage output. So the output voltage will be equal to that R1, let's call this R1 and R2. So it will be R1 from our formula here that we had already derived. So it's going to be that resistor here, divide that by the total resistance here, multiplied by the voltage input. So it's going to be R1 over R1 plus R2, multiply that by the voltage input. So R1 is 4,000 ohms over 4,000 plus 4,000, which is 8,000, multiply that by 100, and we shall get our answer as 50 volts. Now 50 volts, that's going to be our answer. That's the voltage output for a potential divider that is unloaded. Now let's look at a case whereby the potential divider is loaded. We are having this question. If the divider below is loaded with 400 ohms at the output, so we are having here 4,000 ohms. This is a resistor with 4,000 ohms at the output, and the resistance of the divider is 8,000, so this whole thing is still 8,000. Find the PD across the load when the slider is 1/4 up the divider. If the slider is a quarter way up the divider, it means that a quarter of 8,000 gives this bottom part between this and the divider. So this bottom part has a resistance of 2,000, and this upper part has got the remaining bit, which is 6. So meaning that 6,000 plus 2,000, making it 8,000 volts. It also has an input voltage of 100 volts. So it means that here our R1 is 2,000. Our R2 is 6,000. So now, for us to get the voltage output, the voltage across here, we remember this is loaded with another voltage, with another resistor of 4,000 ohms. So we need to first find the effective resistance here, so that when we get the effective resistance here, then we can apply the other. So the effective resistance across the 4,000 and the 2,000 here, so we shall get the effective resistance, we shall call it the effective resistance 1 over R is going to be equal to 1 over 4,000 plus 1 over 2,000. And when we add this up, our effective resistance across this combination is going to become 4,000 over 3 ohms. That is our effective resistance across the output terminal. So it means that after getting our effective resistance here, it means that our divider has now become like this. Our potential divider has become like this. The effective resistance here, which is 4,000 over 3, has now become this, and now this upper part is 6,000 volts. Now we get the voltage output there, like that. So we apply our equation that we had derived before, that it's going to be this resistor, divide that by this plus that, times the input voltage. So to get this voltage output is going to be equal to that 4,000 over 3, divide that by the total, which is 4,000 over 3 plus 6,000, this whole thing multiplied by 100. And when we do that, our answer for the voltage output will be 18.18 volts. And that is how we calculate for voltage output for a potential divider that is loaded. And our previous example, we are dealing with the case where the potential divider was unloaded. This brings us to the end of this video. Thanks for watching. Somebody out there would like to watch this tutorial. Please don't forget to like and share. For more videos, please simply subscribe to this channel. Catch you in the next video.